Assalamu alaikum. My name is Maqsood and I'm a student of a University Islamabad and I'm currently doing mechatronics engineering. Today I'm here to show you my lab 10 task of microcontroller and embedded system lab. So basically here it is named as lab 3 FPGA. So basically we had to do these labs on Quartus. So basically first of all I will let you know what is Quartus. So Quartus is programmable logic device. Basically it is a software produced by Intel prior to Intel's acquisition of Altera. The tool was called Altera Quartus Prime. So basically, it is basically based on Altera model same. So for Verilog HDL codes. So basically, it enables analysis and synthesis of HDL designs, which enables the developer to compile the designs, perform timing analysis, examine RTL diagrams, which we have used also, simulate the design's reaction, and configure the target device with the programmer. Quartus Prime includes an implementation of VHDL and Verilog for hardware description. So basically, for hardware descriptions, we have used this Verilog language, Verilog HDL language. So basically, this was all for Quartus. So we have downloaded Quartus 13 and 15 versions. So first of all, I will let you know what is FPGA. So just like microcontroller, FPGA is an integrated circuit, but much more advanced than that. It is very costly, but and very efficient than a simple microcontroller or Arduino. So it is an integrated circuit designed to be configured by a customer design after manufacturing, hence them field programmable. So basically, it has many things. It has USB ports and different uh, things installed on its hardware. So basically, FPGA configuration is generally specified as using a hardware language HDL, which we have used, and circuit diagrams were previously used to configure the configuration, but this is increasingly rare due to advent of electronic design automation tools. So basically, it is far better than a simple microcontroller. So first of all, we had to implement these codes which were given to us in Quartus. First code was based on arithmetic operators, yeah, which means simply adding, subtracting, multiplicating, division. So basically I ran this code in my Quartus. Second code was logical operator, uh, which means and operator and different operators, not operators. So basically, the logical operators are logical and logical or and logical not, basically gates. So I implemented this code in my Quartus. As you can see here, I implemented this code in my Quartus and named the file as lab10.1. Then I compiled this file by using Control L, and it was successfully compiled. As you can see, basically this is a feature of Cyclone 2. It compiles very quickly as in comparison with Cyclone 5. So basically, it, as you can see, it was compiled successfully. Then you have to go to lab 10.1, locate, and use this RTL viewer. So basically, it will show this kind of schematic of our logic. So this was the schematic of our logic. Then we have to go to lab 10. So we had to go to locate. So again we had to go to new and select university profile VWF. We have to click OK. Then we have to click on file. Sorry, here we have to click insert node or bus. We have to click on node finder. Then we have to click on list. This list will be appeared. Then we have to do this step, press OK, and then these are the inputs and outputs. Then check that which one was your input and which was your output. So basically, ABC was our input and DEFGH was our output. So basically, I will give ABCD as our input. As you can see, we had to give this input through this. As you can see, let's suppose I have given 80 to this. So basically then I will give 40 to B, period, and then I will give 20 basically this was our input. And when I run this code, so basically it is compiling. Another tab will be open. So basically this was our output. As you can see, ABC our input, and D, E and F, G, these are all our outputs. So basically this is how you produce waveforms, how you produce simulation, and how you code in this Quartus. So basically we had to do this. Then we have to create a pin planner, and this is how we have to do this on hardware. We have to configure pin number on this, and then we have to connect that pin on FPGA board. So basically this was first exercise. Then I have implemented this exercise in which we have used relational operators. Relational operators are less than, more than, or equal to, and more than or equal to, so that these true false values are defined in the same way as above in the logical operator. So basically it compares both values and then tell us that which one is greater, which one is smaller, which one is equal to the other value. So basically I have coded this in my Quartus. Same, I will apply the same steps here. I will locate it in RTL viewer for simulation. So its simulation will look like this. Then after going into pin planner, I will do the same steps as before. I will give it input pin to configure it on my FPGA in hardware form, and then I will click on new, go into insert node bus, node finder, list. So basically let's check which was our input. So A, B, C, D were our inputs. So let's give 100 here, or 120. Let's suppose give 60 to B, 60, C 30, D 15. We have to give them on equal intervals. So basically whenever I run this simulation, as you can see, it is successfully compiled. Now we will see our waveforms. A was our input, B was our input, C was our input, and D was our input. E and F and G and H were our output. So as you can see here, our waveform will look like this. So we have to implement other codes like this as well, equality codes. I've implemented all these codes here, as you can see in my lab 10. So I have implemented all these codes here, and in the same manner we will display our waveforms. Pin planner, we will display our schematic, just like we have done in first two codes. So this was all for my lab 10. Thank you.